So you understand what I'm saying? If any of you try to help me and answers, I'm gonna give extra point inside the blackboard directly. Like I'm gonna have a piece of paper here, I take names, and then I will add extra point for you into the first quiz. Okay?
Just sitting up straight so that I'm getting ready to.
Huh? So you know,
Yes.
you know, you never seen digital logic design, right? This is something quite new for you guys. Everything before it was like 1 + 1 is equal 2. Now we have 1 + 1 is equal 0 sometimes. So you know, it's kind of new for you guys. So I'm trying to help here. Okay, so I'm trying to help. So basically, you know, I'm going to ask people randomly, and then you know those people. You know, if you answer correct and you are helping me with the answers, I will give like 1 point or 2 points extra in the top of your grade on the blackboard. Sounds good?
Sounds very good.
Good. Yes.
Everybody fine with this?
Very appealing.
Yes.
Okay, so maybe we can start with what? Jeremy. Jeremy, can you tell me what should I do with this?
Sorry, I was just pulling up what I did because I remember I got this right. Give me a second.
Okay, tell me, what should I do?
So since this is in the 4, it's to base 4, I set it up so that it went to decimal. So I did
You converted
4,
to decimal, right?
yeah. I did 3 times 4 to the 0, and then 2 times 4 to the 1. Plus, yeah. And then because of that, I got the decimal for which was 11, please. Yeah. And then from there, I converted to hexadecimal, which was base 16. So you're able to, from that, find E2.
So do you think what I'm doing is correct?
Yes. Yes.
Okay, so Melvin, do you think I'm correct?
For number 1, part A?
Yeah, do you see in front of you what I'm doing, right? Is it correct?
Yes, I do agree.
Okay, so now because Jeremy, the one who actually helped me, so you know, Jeremy gonna get extra points. Jeremy.
Nice.
Yeah, you're gonna help me soon. 1 plus. Okay, now who would like to do the second part?
I can do it.
Jennifer or who?
Oh, yeah. Sorry.
Okay, Jennifer, tell me what should I do with this?
Okay, so basically, I converted from 12A base 12, and I did 10 times 1 plus 2 times 12 plus 1 times 12 to the second.
Why is it like this, right?
Yes. Because you're essentially converting to A base 10.
That's what you did, right?
Yes.
Then you divide after that with 16s and you get
Yes.
right?
Yes.
So do you guys think that she's right?
Yes.
Definitely.
Is there another way?
Can't you convert it to a different base if you wanted to, and hexadecimal?
You could go directly, since you know that hexadecimal goes from 0 to 15. You can just remember that 12 is B, and then A is.
So can we try? Can we try it?
Yeah.
Okay. Okay. So you know, 16s is basically 0, 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, right? Those are the hexa, right? Then, you know, if I would like to convert the 12, so the 12 is what? 0 to 11, right?
Yeah, that would be C. But actually, I just remembered that if you do this method with this one, it wouldn't work. You have to divide by 16. That's what I did.
You have to divide by 16, exactly.
Yeah.
And it will give you the same answer like the one in the top, right? Did you guys try it?
Yeah,
Yes.
that's what I got.
Yeah. Yep.
Okay. So, Jennifer, you got extra points.
Thank you.
Okay, you're welcome. Now we gotta move to this one. This is really easy, right? So I'm not gonna ask anybody to do it. I'm gonna ask people now for the more difficult parts, right? So this one is pretty much easy, right? Why? Because this is what is unsigned. So the last bit is not involved with the sign. Do you agree?
Yes.
So converting this to decimal is gonna be what? 2 power minus 1 times 1 plus 2 power minus 2 times 1 plus 2 power minus 3 times 1 plus 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 3 times 1. And that will be the equivalence, right? I'm talking about this one.
Yep.
Everybody's fine with this? Okay. Now, the other one is going to be almost the same. So far, anybody in this room, in the Zoom room, have any question about question number 1 and question number 2? Christopher Honda? Okay. Now we're going to move into this one. This one is it hard? That was really hard for you guys, this questions, or was it straightforward as well, right? Because you already have what, 17 power 0 something with J plus 17 power 1 times 1, right? This one is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, G, right? So that's actually 10, 11, 12, 13, 14, 15, 16. So this is basically 16th. If you do this, automatically it will be the decimal, right? So this question also is good. Okay, now we are coming to this question, the people who don't like it. But actually, a couple of you actually did it correct. So
I was very unsure about this one.
No, but 90, I'm serious, a couple of you did it really correct. So, but, let's do it. So basically, I don't want to go to base 10, and I want to do it like somehow, like direct. So how you can do it is pretty much easy. This is base 3, and this is base 9, right? So that means every single 9 will be 2 digits of 3. And let's see what does this mean. 3, that means the number per digit is going to be what? 0 and 1 and 2. That's it, right? And those are 3 numbers, right? So if I would like to get 9, 9 is what? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is not exist because, those are 9 numbers, right? So 0 to 8. Now I need to see the equivalency of them. So equivalency of them just count, right? Here, 0, 0. There, 1, 0. Here, 2, 0. After that, it's not 2, 0. It's not 0, 2. It's gonna be 1, 0. Then it's gonna be what? 1, 1. 1, 2. After that, it's gonna be 2, 0. 2, 1. 2, 2. So do you see what I'm doing? In the normal decimal, right? You're right. The digit is 0 to 9, right? So if you have multiple digits, you are expecting to be, let's say 2 digits. So you are expecting to be from 00 to 99, right? But because this is actually base 3, so that means you can count up to 2 per digit. So that means 0, 1, 2, and then 10, 11, 12, 10, 20, 21, 22. Then after that, what? 30, 31, 32. Then 40, 41, 42, and move forward, right? So you are looking for the base, and you are just taking equivalence, right? Now you are looking to this problem in front of you. You already have the 9th point or decimal point, whatever you call it, right? So I have in this side 5. So I look to 5, and I find the equivalency of 5 is 12. Then I look to 7. What is the equivalence of 7? 21. Then I look to 1, I found it is basically 0, 1. And then I look to 4, I found the equivalency is 1, 1. Then I found 3 is the equivalent is 0, 1. So basically this is going to be what? In 3 as equivalent of the 9th. Now, is it clear to everybody?
Yes.
Just for
Yeah, sorry. Okay. Just for more clarification, does this only work when the base is like a power? Like, okay, so 9 is a power of 3. Does this only work when that is true? Like if
Work with anything, let's
like
yes.
like a 8 to 3, 8 to 3 or something.
Let's do 8 to 3. That's no problem. 8 to 3, right?
Mm-hmm.
So 8 is basically 0, 1, 2, 3, 4, 5, 6, 7. Right? So now it's gonna
Yes.
be what? 0, 0, 1, 0, 2, 0,
Oh, okay.
then 10, 11, 12, 20, 21.
Oh, okay.
Okay?
For me, I got this case and I was like looking at it, and then the thing is, I tried to convert it out. I like just to check it. I converted it out of base 3 into decimal form, and it wasn't exact. It wasn't like equivalent to the other answer, so I thought it was wrong.
No, no,
So
no. This is the right way.
oh, okay. No, well, no. I thought the like ending answer in base 3 was wrong because I thought like with 0.5, like with decimal, and when it's base 3, it's like never ending.
Oh, okay, I get your point. No, no. Normally, when people say something like that, you don't go to decimal, then you don't need to go to decimal. You have to do this trick. You have to make equivalency table. So you look to the
Oh, okay. Thank you. Yeah, thanks.
Sir,
yes.
can you give us the same example but with like different numbers or like different bases?
Yeah, I mean, that was who actually asked me for this.
That was me.
Joseph, right? Joseph said, 8 to 3, right?
Somebody put in chat like 9 to 4. That would be
Yeah, that was me.
Oh, let's make 9 to 4. It's not a problem, right? 0,
Thank you.
1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Let's take the equivalence here. It's gonna be 0.
It doesn't go to 9 if it's base 9.
Huh?
If it's base 9, it doesn't go all the way down to like it
Yeah.
stops at 8.
I'm sorry, you're right. So gonna be here 0, 0. Gonna be here what? 1, 0. Gonna be here what? 2, 0. Now that's 4, right? So gonna be 0, 3. Then it's gonna be 10. Then gonna be what? 11. Then gonna be 12. Then gonna be 13. Then gonna be what? 20.
Oh, okay. All right. Okay, that solves everything now. Thank you.
You are most welcome. So any other question regarding this part?
That was for base 4, correct? Base 8. Base 9 to base 4.
Because
Okay.
Look at this movement. 4, that means 0, 1, 2,
Yep.
3.
Gotcha.
So is it clear to everybody?
Yes, thank you.
You're welcome. Let's move forward. So this is the one you guys like. Do you know what is the output of this? Somebody tell me.
It was Z,
Z, exactly.
and I didn't get it.
Yeah, I didn't get it either.
Sorry.
Man.
Why
Me
complement?
neither. That was hard.
You know what? Listen, the whole idea that we are learning here, right? And it should be straightforward. So let's try it. It's no problem. This one is super cool, right? Look at it. This part is really fun. Why? Because W ended with W complement. Right?
That should be Z.
So
It goes to 0.
yeah. Let's do it together. It's not really hard. So this one is gonna be what? It's gonna be Y Z ORed with Y X complement, right? W, right? Times W complement or Z. Is this correct? I'm talking about this term.
Yes.
Let's take this term further. So basically, that one is bye-bye, right?
Yeah.
Because it's gonna be Y Z ORed with Y X complement W complement with the Y X complement W Z, right? This one is 0. Do you know why it's 0, right?
Yeah, because the Negate.
All right.
Then we just have those two, right? Let's look at this fun. You know, this is fun. Take it more. So it's gonna be what? It's gonna be y z like this, 1 plus something.
Yeah.
Right?
So it's just one.
Just one. Yeah.
Bye. So it's gonna be y1. So basically, you know, this thing, it turned into be just yz.
Yeah.
So far, so good.
That's why I got that part.
Okay,
Yes.
good. You did a good job. You know, see, you know, just trust yourself, right? Now let's do the second term. So we are taking term by term and then we combine them at the end, right? What is the second term? So the second term is x y complement with the complement of x with y. So De Morgan, so gonna be what? It's gonna be x complement y complement like this, right?
Mm-hmm.
Yes.
Right?
Yep.
So now we have this with it, right? So those two guys end up to being like that. Super good.
Mhm.
Is there any modification? Is there anything we can do here?
Yeah, you can actually. Yeah, what he said.
Could you say it again, please?
Yeah, my my phone also is learning. You know, you know, my phone is attending. You know, what's called a
It's artificial intelligence.
They're tracking me. I don't know. Anyway, we go back to the point. It's gonna be y complement x complement. Everybody agree?
Yes.
Then
Yes.
this is what? This is
One.
one,
Mm.
right?
Yep.
So now we have what? We have y complement odd with z complement, and that's actually odd with y z. Is there anything else we have to do here?
No.
The one who made it z, is there anything we have to do here? A couple of you, by the way, give it to me z. Leave it for now. Okay. Now let's take this. Let's take this part because this part is huge, right? It's dense. We have to work on it, right? So how can we do it? We're gonna do it as a following, right? It's gonna be z y complement, right? Or with w y complement z. Is this correct? Then that will be ending what x z complement. I'm right?
Yeah.
Now this part is gonna be x, right?
Yeah.
So now we have what? We have z y complement with the w y complement z x. Can we do anything here?
Yeah, you can take out his
right?
ZY complement.
And take this,
Yeah.
and take this, and then those guys bye-bye, right? So this gentleman is just what? Y complement z. So far, so good?
That's where I messed up.
Now, we will take this, right? To add it to those, right? So this one with those guys are z, right?
Okay.
So now we have what? We have z ORed with right? So that's gonna be what? That should be y complement.
Wait.
Wait a minute.
I got
Wait,
one.
but I got that. Wait,
But I got that.
Oh, what?
wait, that's what I
Does
got.
that mean we're done?
We need to try it again.
Oh my
There's
gosh.
Did you prank us? I'm confused. Wait, did we
I
get
mean,
it
did, I,
right?
did I get full credit? I'm just being bugged.
Holy crap! Wait.
Oh my gosh, people here are happy.
Wait, oh.
Yes.
I'm like, wait a minute. That's what I got. This is good.
Did I go up 16 points just now?
Yeah, you're gonna get a lot of points, right?
Oh my god!
No, let's clear it. Let's clear. I know that should be Z. So 1 second.
The professor just wanted to make us all happy. He actually
know,
changed
huh?
the problem so that we can get it right. This answer,
Makes
because he knew
sense.
everyone got this answer.
Wait.
Good
I'm gonna make everybody happy. So don't worry.
Is this like a multi-answer problem or something?
It
I
can
think
be.
we should come
Oh, no,
to
it
a
can be.
compromise.
It can be.
I think that since you got Y complement at the end, and that's what we all got, that must be it. Obviously, I mean, like
Yeah, we
process
should get some
elimination
points
and
for
everything.
that, Professor.
I do agree.
No, I don't agree. Wait. Let me do
Can
it
we
again.
vote? Can we vote on that,
No,
This
we
Professor?
cannot
is a
vote.
democracy. I think we all won.
No, we
Can
cannot
we
vote.
get at
1
least
second.
60%?
1 second. 1 second. I know that should be actually wide. Maybe there's something missing. So anyway, let's do it from this side first.
The first two were right, which you did, Professor, because I got the same thing as well.
There's something missing for sure. So 1 second. So basically gonna be here Y complement Z, right? With W
Yes.
Y complement Z time X Z X Z complement, right? So that's basically this guy will be what? Y complement Z, and that's gonna be W X complement,
Yeah.
right?
Yes.
Which is basically these two guys will go together here and take the WX. So gonna be Y complement Z. So far we agreed about this part, right?
Yes.
Yeah.
Let's go to the second part, which is the part which is unknown everybody here, right? Okay, so this guy is X, Y complement with the X complement, Y complement, right? With Z complement. I'm right? So then, this Y complement will be coming out, right? And this X will be taken out. So that should be what? It should be Y complement Z, and then, Y complement and Z. I'm right?
Yes.
Professor, I have a question.
Yes.
How do we end up at just Y complement Z 2 lines up?
You mean here? I'm just moving by term. So this term is coming from here.
Oh no, just right above that, where it's W, X, Y complement, and Z all ANDed together. Did we just get rid of those?
No. You mean this?
Yeah. Did we get rid of that right side?
You know why this? What happened here, right? That's basically.
No, not yet.
I will tell you. Gonna be Y complement Z, and then one ORed with WX. Anything one with ORed is gonna be 1. Do you understand?
Gotcha.
Okay.
Gotcha. Thank
Anyway, now we're gonna go into the last part, right? To add it into the system, right? So the last part is what? So the last part is gonna be Y Z ORed with W X complement Y and W Z. I'm right? I'm talking about this last part. Leave this one, still we need it, right? So here, so gonna be Y Z with W X complement Y W complement, then W X Y Z, right?
Yes.
That should be added also to these two guys. So gonna be Y complement Z with Y with Z. I'm right? Now, this is gone, right? So we
Yes.
just have an equation now. Say Y Z is W, X, Y, Z. Then Y complement Z. Then Y complement Z complement. Right? Now, we need to do some tricks. Right? So this 2 will bring me Y, Z. Right? Then we have Y complement Z. Then we have Y complement, we have Z complement, right? Do you understand what I did or no?
Yes.
Yes. So now,
Yeah.
Now, this one is gone, right?
We're gonna, yeah, I was about to say that.
So gonna be Y, Z with Y complement with Z complement, right? That's another answer.
And then
There's something is missing here.
I think it can be simplified further.
It should be simplified further, yes.
Is it alright if I give an explanation for that part?
What, sorry?
So I think for this one, it's similar to, you can apply De Morgan's theorem. So it would be a Y complement or with Z complement.
Oh, you mean you will take this?
Yes. Then
So you mean they're gonna be Y, Z, or with Y, Z complement like that, right?
the reverse. So so it would be let me see. So the YZ, the Y and Z.
You mean this, right?
Yeah, that one.
What you gonna do with this?
It would be Y complement plus Z complement, and then complement over all that.
Okay, and then?
And then, as you can see, the term that's under the complement, Y complement or with Z complement, it pretty much simplifies to like the what is that? Let me give like an arbitrary variable. Like they're the same, right?
It shouldn't be 1. No. I know what you're talking about. No.
Professor, can I say what do I think is gonna be going on?
Huh?
Can I say what I think the steps should be?
I see. I think I made a mistake somewhere, so I need to find it. I think I picked something from up or down. Maybe what we can do it again. It's no problem, you know. Here we are learning, so I think there is something is missing. So I need to clear up this. Okay, so let's do it again. So Y complement W, Y complement X, Z, and there's another Z, so the Z will be over, right? Oh, now I figure out what's the problem. You know why? Look at this inside this Z. It's actually taking it.
Oh, wait, can you repeat that?
Okay. Now I understood the problem. Look. You know, I think the best way to do it is to actually completely open it. You know, take all the things that like term by term. So look here, right? Is Y complement Z, right? Then there's gonna be W, Y complement X, Z, Z, right? Then, huh? Hello? Somebody say something. W, Y complement.
Oh no, I just
X, Z complement Z, right?
Yeah.
Then we will go into this one. This one is what? X, Y complement. X, Y complement like this, right? And Z complement, right?
Mhm.
Then this will be what? Y, Z. Then W and X gonna go in Y also. So gonna be here plus Y, X complement, right? Y, X complement, W, right? W complement, correct? Then they're gonna be what? Y, W, X complement, Z. So now we already opened what? We made it all possible what terms. Do you guys agree?
Yeah.
Everybody see any arrows? Because I'm writing fast.
Okay. So you're taking that Z on the outside and just putting it in each one of
I'm
them?
just like making it terms. Have you noticed?
Because
Right. So this one is causing the whole thing to be 0,
yeah, okay.
right? This one, Z as it is, right?
Mhm.
So basically you already have Y complement Z, and then you already have W, X, Y, Z, right? And then X, this one is gonna be just Y complement, right?
Yeah, okay.
Then we have Z complement, right?
Mhm.
Then we have another YZ, right? Which is this one. Then this is gone, right? Then we have Y, W, X complement Z, right?
Okay.
Now we need further what? Optimization. So let's see what we can do as an optimization. One. Those two guys are Z.
Mhm.
Do you agree?
Yes.
Yep.
Those two guys are Z, right? Then I have Z complement gone, right?
Mhm.
Now that system, it should be what? It should be Y complement with W, X, Y complement Z with Y, W, X complement Z, right? Then you can make this, these two guys need to do something together. So basically gonna be what? Y and W, Z, W, Z together. And then you already have what? Y complement W, Z, W, Z, W, Z. And then you already
We have the X and the Y complement.
like this, right? That's not optimization. We missed the optimization.
No. I said that we have X and X complement on both sides, so they will cancel out.
Which one?
Let me see if I can annotate so I can point it out. I can.
I think because you have the X and the X complement on one side and the other side, so they cancel out, and then you have the Y complement and the Y.
That's actually, that's canceled the whole thing.
Yeah, wait, Professor?
Yeah.
Since you have, you reduce the Y prime Z and the ZY to just Z, and then you have a Z prime, and that cancels out to 1. Doesn't that just make the whole thing 1? Because it's ORed. Everything's being ORed together. So if you stick a 1 in there.
That's gonna be Y complement.
Mm-hmm.
You understand what I'm saying? But then I didn't make enough optimization. That's actually not optimization. You know what? What is our target? Optimization. Y complement can be correct. Z is correct. But then you know which one is correct? Z. You understand what I'm saying? Because you are looking for the lowest number of gates.
Oh, because, yeah, okay. So
anybody can give me any answer, but you understand?
yeah, okay.
So that what
Because
is
Z is correct because there's no complement, right? I guess.
yeah, I mean, yeah. So you understand what is the final target, right?
Mhm.
Anybody can bring anything, but we are looking for optimization. When we say minimum, minimize the function.
Okay, Professor, can you go scroll down? I have a quick question.
Mm.
So on this step, go a little bit up.
Mm.
So if I take W
Mm.
and Z as a common factor, and then do you kind of know what I mean?
Which one? Let's start from here. So talk to me from here.
No, never mind. Never mind. It's all the way down, but never mind.
Just 1 second. Let me see something. I'm just checking how many of you already answered. 1 second. I know that a couple of you did it Z, which is correct. So who actually the one made it Z? The one who made it Z. You still remember how did you do it? Hello? Melvin, you did Z, right?
No, I got Y complement.
You did Y complement. So anybody did it Z? I have seen it. Somebody did it Z, but who did it Z? Juan, what did you do?
Professor, honestly, I think you should cancel this question from the homework, from the quiz.
That's hard to cancel because it should be Z. But okay, here. Let's take some break from this and move forward to the rest, and then I will start again. Okay? And go on this question. Is this question hard? How many of you already did it?
I know I could do
Was a
that.
challenge.
It wasn't much of
I
a
got
challenge.
this one.
Yeah, this one was fine.
Okay. So who would like to do it?
I can do it.
Let me pick. Andy. Andy,
Yes.
can you do it, please? Can you help me with the first one?
Sure. All right. So to prove this, I did that equivalent to A complement B plus A B complement, and the entire thing is complemented.
Okay.
That equals to A plus B complement times A complement plus B.
Is this correct? What I did?
Yes.
Okay. And then
Then I multiply them together, and I got A complement plus AB plus A complement B complement plus B complement B.
It's correct.
Yes. And then wait.
Okay. Then we'll take the other one. The other one is what?
The other one? Wait, hold on.
Because I need to see whether they are same or not, right?
Yes. Oh, I did. Okay.
Right?
Yeah.
Do you guys have any question about this? Is it clear for everybody?
Yeah.
Okay.
I did it a different way, Professor.
Then what's your different way?
Oh, okay. Well, I started off with the same expression. Oh, wait. No. Okay, yeah. I think we did the same way. It just looked a little bit different. Our steps. This is
okay.
De Morgan's complement, right?
Okay. So
Yeah. Okay, then we did the same way. I'm sorry.
Yeah. So who would like to make B? So you can get extra point.
I can make B. Oh, never mind. You were first.
No, you could go, Joseph. No, you're good, Joseph.
Oh, thanks, man. Yeah, all right. I can do B professor if you'll let me.
Of course, I can let you. 1 second, just let me find the page. So what is B? It's this part. So tell me, what should I do?
All right. So
Maybe I can make it here.
okay. So I turned the XOR into AB complement plus A complement B.
Okay.
Then times CN plus A times B. And then you distribute the CN. So you'd have, CA, all that plus AB.
Mhm.
And then I used I took out the A from the C and B complement in the B. So it would be C and B complement plus B plus C and A complement B.
Mhm.
Yeah, so that's just the law. And then I used the De Morgan stuff. So the B complement in the B just turns into regular B.
Mm.
So it would be A times CN plus B plus C and A complement B.
Yes. So
Okay.
is it correct?
I know, I think I'm going too fast, which is my fault. I'm just reading directly off my grade scope paper.
So is he correct? Jamal?
Is that all the answer was?
No, there's still like a ton of lines left. I made it all complicated and everything, but I think there's an easier way. But
there's an easy way. So maybe Juan, can you do it? So give me your name.
Yeah.
Right.
Joseph.
Who actually answered? Can you?
Joseph.
It was Joseph.
Joseph? Joseph what?
Molina.
Joseph. Yeah. Molina. Okay. You got extra points.
Thank you.
So Juan, tell me, what did you do?
Okay, so let me just get my stuff. So I actually started with the. Actually, I can share my screen if you want to.
Share your screen.
I don't know if you want that.
If you guys are fine with that, you can share your screen. Go ahead.
So this is my part B. So I actually started with the left-hand side, and the goal was to end up with the right-hand side. So I started with this left-hand side, and then you go to the right-hand side. And the way the proof works is by doing a series of equivalencies. So I first was on this left-hand side, and then I expanded the XOR A not B over not A B, and then ANDed with CN or AB. And then right here, you can notice that you can take out an A, so you have B or B not CN, and then don't forget this term, not A B CN. All right, then you got equals this one, so I move this guy to the left-hand side right here, and then I have A, B or B not CN. So then that's B or B not distributed across the addition. So then you have B or CN, and then you go over here. So this is the left term, not ABCN or AB or ACN. So distribute the A right here.
Perfect.
So that's right here.
So you have Juan. So let me see. Juan what?
Manriquez, yeah.
Yes, exactly. So you got +1 as well. Okay, so we finished this. So one of the things, I'm gonna go to number 7, then I'll return it back to the optimization. We have to do this optimization. We're not gonna leave until we finish it, Okay, now, for this one, 90% of you did it correct, but maybe some of you already got confused, but I need to see why they are confused, okay? So look at this, right? This is basically a practice of K-map, right? So you already have 1, 2, 3, 4, 1, 2, 3, 4, and here is basically A, B, C, D, and then 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, and then here is 0, 1, 1, 1, 1, 0. Am I right? That's 8, 9, 11, 10, 12, 13, 15, 14, 0, 1, 3, 2, 4, 5, 7, 6, right? Then we said 0, 1, 2, 3, 0, 1, 2, 3, 8, 9, 9 what? 10, 11, 12, 13, 14, 15 are the one we have. Everybody agrees me? So how many groups should we have here? Who gonna reply?
2 groups.
Who's talking?
Luai.
So Luai, go ahead. So
Okay, so I'm gonna start with the all 4 at the top and the 4 at the bottom.
exactly. So I noticed one of you actually made it to me wrong in a way that, just like isolate the one in the top. So, Luai said we're gonna do it like this, right? And they're gonna
And
be
that's group 1.
Then where's
And
group 2?
all the 6 at the bottom.
This is
Sorry,
group 2,
the 8 at the bottom. My bad.
right? Which is basically end up being A plus B complement, something like that, right?
Yes.
So, building this circuit is not really hard, right? Using NAND gates. You guys agree? So pretty much it's gonna be what? It's gonna be like this. I'm right? Is it correct?
Okay, so I did the
I got
opposite,
the same.
Professor.
So the one who did it like this, he got the final, basically got the grade. So
I got it that way.
yeah, I mean, I'm not saying names or something, but some of them, the problem came for like this. It shouldn't be like that. So of course, anything built based on this would be wrong, right? You understand my point? So anyway, back to the most important and interesting question of this quiz, right? Which I love, I like challenge stuff. So this guy, let's do it again.
Professor.
One more.
Yes.
Okay. I for that one I got 1. Can I share my screen just to see?
No, I know that you're gonna. Sometimes you get 1, but it has to be a parameter. It can minimize the function. You understand what I'm saying? When anything can come out. I already in front of you got a Y complement, right?
Yes.
So I understand. You can get many things. I'm sure that slightly mistake I made, and then I optimized something, and then we didn't even notice. You know what I mean?
Professor, for this time, could you try maybe simplifying everything from inside the parentheses before you simplify or distribute everything else?
There is a way to do it in a different way. You know what? You can make it what min terms, and you can see the truth table, right? That will be the final. You understand what I'm saying? So you guys, if you can do it, next time I can add everybody a point for that. You understand what I'm saying?
Mm-hmm.
So what I'm saying, you will try to bring all of them in terms of this. I know pretty much sure this part for sure is basically Y complement Z.
Okay.
That's for sure, pretty much sure. Let's see why. Because, look, it's a Y complement Z, right? Added to, this is basically what?
X.
It's going to be WY complement Z. Then add it to this X. So you're going to take this together to be what? Y complement Z and 1 with WX. Z. 1 WX, I'm sorry. This one is basically 1. Did you see what I did?
Mm-hmm.
So you guys are following what I did or not? Okay. Now the second part is basically this part. This part, if you do it like this, it's gonna be this part plus this part. So you already have here X, Y complement with the X complement, Y complement, right? With Z complement. I'm right? Then that pretty much is basically what? Y complement, Z complement. Is it correct? Then this part is pretty much very simple. So, gonna be here y, z with w, x, z times w with z, something like that, right? So gonna be y, z, and this will be ORed with, so you're gonna be what? W, x complement, z, w complement, ORed with the w, x complement, z, z. This one is gone, so we just have this one, right? So pretty much they're gonna be y and w, x, sorry, gonna be y, z, ORed with the w, x, z. I'm right?
Mhm.
So here end up gonna be y, gonna be y, gonna be the part, right? So I cannot, can I modify this anymore, or that's it?
No, you can't.
I cannot. So basically, end of the day, we're gonna have y, z with y complement with z complement with y, z with w, x, z. Right? Did I do right? Huh?
So I think you had to distribute the. Did you distribute the y?
I did this right. This is basically it. And then, I think I made something wrong. Somebody can correct me, please. What did I do? Somebody tell me. There, right here. If I distribute w here, it's gonna be gone. So it's gonna be y, z, and this is gonna be gone. So then, end of the day, gonna be what? It's gonna be w, x complement, z, right? This is basically the part.
Wait, but there's a y in there, right? Because you're distributing it to both.
There is y here. You're right.
Yeah, okay.
I'm right. But then, this yz is gonna take this out, right?
Mm-hmm.
So everybody agrees with me? So basically we have what? We have y complement z, and we have yz. Do you see what I did? So, that came from here, right? And that came from here.
Then y complement cancels and it's just.
Now it makes sense?
Mm-hmm.
But we didn't take this into consideration yet, right?
Yeah.
So let's see what is this actually inside this. It's gonna be x, y complement with x complement y, and z, right? So that's basically y complement z. Right?
No,
wait,
it's a
shouldn't be a
z
Z complement.
Yeah, it's a z complement.
Is it z complement? Seriously?
Yeah.
The last Z.
Oh, you're right. So it's gonna be y complement z. So basically here is gonna be what? It's gonna be y complement
Plus
and
z
equals z. I'm right?
Mm-hmm.
Yeah.
So now this guy with this guy gonna give what? Y complement was yz. That's basically what we should have.
Wait, what?
I don't get that at all. Could
Wait,
you
what?
ask the question?
Wait, but don't your y's cancel? Then you just have z times 1 because of that. Z cancels and then it's y complement.
Which one? Tell me.
On that last line, you have y complement z plus yz plus y complement plus z complement, right?
Yeah.
I thought that you'd factor out z and then y complement and y would cancel. And then you just have z plus z complement, those would cancel, then you just have y complement.
Okay, so what should we write here?
I agree 100%.
Okay, so tell me what should I write? Huh?
I was gonna say it
This
should
part,
be z.
This part we agreed, right? This part is the same.
Yeah.
Yeah.
Let's go to the other one because this one is the confusing part. Okay, so it's gonna be odd with what?
Just the line right above y complement plus yz.
Y complement plus z. Okay. Then we have yz as well, right? Because yz came from here, right?
Yeah.
Yeah. Professor, if you scroll down to the bottom, you see complement yz or yz, you can factor out a z. But the problem is if you factor out a
This is
z,
exactly what I did.
yeah, if you factor out the z, you have z or z complement or y complement. Z or z complement is a 1.
Equal 1. So
Yeah, so
you have
when
1 or
y
1 or
complement.
y
So
complement.
anyway, what I can do is the following, just to to remove the confusion out of this question. Okay. So specifically for this question, what I'm asking everybody here in the course, right, to do one thing. You're gonna make what main term out of this. Okay, and you will make a truth table out of it and use K-map.
All right.
Right.
Sounds good.
And everybody will do by himself, and you will come back on Monday. You will show it to me before you guys Monday you're gonna have a midterm, right?
Was it
Thought it was
Monday
this
or is
Wednesday.
it Wednesday?
Huh? Wait, this coming Wednesday you have a midterm, right?
Okay, yeah,
Yes.
yeah. I thought you said Monday, so I was confused. But yeah, it's Wednesday, right?
I'm sorry, Wednesday. I'm sorry. So in that case, in Wednesday you're gonna have this. So I will do one thing just for practicing because I'm not here a monster, right? I'm gonna give all of you 20 out of this question.
Yay.
Thank you, Professor.
Did you what I
Okay,
said?
cool.
So
Yeah.
all of
Thank you.
Thank you.
Thanks, Professor.
So you have an extra 20.
Thank you, Professor.
But I'm taking here for research. So for research, I want you guys to do main terms out of it, and you will show me what is the K-map equivalent. Sounds good?
Will do.
You want the
Yeah.
K-map equivalence of what's right here on our screen or the problem itself?
Of this problem,
Okay.
because K-map will optimize it. Okay. Maybe
When
what
do we need-
happened? Maybe because I did it with words, so maybe I forgot. Maybe I think here is a complement. If the complement happened here, then it's gonna be Z. So that's why I don't want to put too much on you guys. So all of you got 20 now.
Oh, cool.
I will leave it in a grid scope as it is, but in Blackboard, everybody will be added 20 on it.
Okay. And
Thank you,
just
Professor.
okay. And just for future purposes, whenever we do this problem, are we always looking for the simplest no complement? Like
Exactly.
always look for that.
No. It's not about no complement. Minimize the function. That means the lowest number of gates.
All right. So that would mean probably doing it more than once to just check.
I got to be 100% sure that you already squeeze it. So do you need my advice? My advice: do it, and then use K-map and see whether the K-map will give you the same thing or not.
Okay.
Makes sense for everybody?
Yes.
Okay. Everybody happy today?
Yeah.
All right. Thank you.
A couple of you got
Thank
extra
you.
point, and all of you got 20 in this question.
Yeehaw.
Sounds good.
Awesome.
I
Thank
want
you.
you guys to be happy. This is the most important part. Okay.
Okay. Thank you so much, Professor.
Thank you.
You are most welcome. So do your best and study. And if you have any questions, I will be more than welcome to assist you. And the midterm, because I don't want to give you too much headache, I can give you also the time of the lecture to do your what's called answering the midterm. So from 8 o'clock in the morning till midnight, you have the whole entire day for answering the midterm. And there is no.
Thank you.
Thank you.
Okay. Awesome. Yep. Have a good day, Professor.
Sounds fair?
Yes.
Yeah,
Sounds
thanks,
good.
Professor.
Okay. Can you promise me to do your best, please?
Always.
Absolutely.
Yeah.
Always.
Good job. Good job. Okay. God bless you. Stay safe. Okay.
Okay.
Professor, God bless. Bye-bye.
Bless you.
Thanks, Professor.
Bye-bye.